Hey friends, so now we're gonna learn how to rank your data using 6 different window ranking functions. We have the row number, rank, dense rank, NTILE, dist, and as well the percent rank. And as usual, first we have to understand the concept behind them, and after that we're gonna learn the syntax, and we're gonna have the most important use cases for the ranking functions that I collected from my projects. So now let's start with the first question. Why do we call them ranking functions? So let's go. Alright, so now let's say that we have the following data. We have products and their sales. If you want now to go and rank your products, first you have to sort the data based on something, like for example, ranking the products based on their sales. So that means SQL first gonna go and start sorting your data from the highest to the lowest. So sorting the data is always the first thing SQL has to do before ranking anything. Now, in order to rank our data, we have 2 methods. The first method, we call it the integer-based ranking. So that means SQL gonna go and assign for each row an integer, a whole number, based on the position of the row. So now by looking to the example, the first row we have the product E with the sales 70, it's gonna be rank number 1. Then the next row, the product B with the 30 sales, we will get the rank number 2. Then the next one gonna be 3, 4, and the last one gonna be 5. So that means SQL here is assigning an integer for each row based on their position in the sorted list. So this method, we call it integer-based ranking. Now let's go to the second method. We have the percentage-based ranking. So in this method, SQL gonna go first and calculate the relative position of the row compared to all others, and then assign a percentage for each row. So here in the output, SQL gonna start assigning percentages instead of integer, and we're gonna have a scale from 0 to 1. So now if you go and compare both of the methods, you can see that on the left side, on the integer-based ranking, we have discrete distinct values. So it starts from 1, then 2, 3, and end up in this example by 5. So it really depends on how many rows do we have in the results. So it could be 5, it could be 500, 5 million, and so on. But in the right side, we have always the same scale from 1 to 0. So between 0 and 1, we have infinite number of data points. And this scale, we call it a normalized scale, or we call it continuous scale, continuous values. So now the question is when to use which method. So for example, for the percentage-based ranking, it is great to answer such questions. Find the top 20% products based on their sales. So this method is a great way in order to understand the contributions of data values to the overall total. And we call this kind of analysis a distribution analysis, where in the other hand, in the integer-based ranking, we can answer questions like find the top 3 products. So with this question, we are not interested about the contributions of each product to the overall total. We are just interested in the position of the value within a list. So this is as well very commonly used analysis in reporting. We call it top button in analysis. So now let's group up our ranking functions based on those 2 methods. For the first group, in the integer-based ranking, we have 4 functions: row number, rank, dense rank, and NTILE. But in the other hand, we have only 2 functions that generate percentage-based ranking. We have the dist and as well the percentile. So now that was an introduction, an overview of those methods and how we group up those ranking functions. Next, we're gonna go and learn about the syntax of the ranking functions. Most of them follow the same rules. So for example, we start always with the function name. So we have here the rank, but as you can see, we don't use any expressions. So they don't allow you to use any argument inside it. It must be empty. So this is the first rule using rank functions. Then about the definition of the window, as usual, the partition by, it is an optional thing. You can use it or leave it. And now to the second part, we have the order by. It is as well required. So you must order the data or sort your data in order to do ranking. So you cannot leave it empty. So that means for the definition of the window, at least we should have an order by, for example, here sales. So we cannot leave it empty. All right, so the 2 requirements, you cannot use any expressions for those functions, and as well, you have to sort your data using order by. Okay, so now let's have an overview of all functions. So as you can see, all those functions are ranking functions, and almost all of them don't allow to use any expressions inside them. Beside this function here, we have the NTILE. It accepts a number inside it. So that means you cannot use it empty. You should use a number inside it. All others, must be empty. So now for the partition by, all of them are optional, and for the order by, all of them are required. So you must use order by, and the frame clause, they are not allowed to use in the ranking functions. So you cannot change the definition of the frame inside the window function. So now what we're going to do as usual, we're going to go and deep dive into all of those functions in order to understand when to use them and what are the use cases, and as well practice in SQL. So we're going to start with the first one, the row number. Hi friends, I just checked the YouTube statistics and it says since the creation of this channel, over 70% of you still watching the videos and the content frequently without subscribing. So here's the deal. If you ever enjoyed watching my contents, please subscribe. It's gonna help the channel more than I can explain, and I promise in return I'm gonna keep pushing on making high quality videos about data. Do we have a deal? Alright, let's go back to the video. Alright, so what is a row number? In SQL, the row number function gonna go and assign for each row a unique number as a rank, and it doesn't care at all about the ties. That means if you have two rows sharing the same value, they will not share the same rank. Okay, so now we have a very simple example. We have a list of all sales, and we have the following query. So it's gonna start with the ranking function, a row number, it doesn't accept any argument inside it, and the definition of the window gonna be like this: order by sales disk. So that means we're gonna go and sort the data descending from the highest to the lowest. So SQL gonna go and do the following. The highest gonna be the 100, the lowest gonna be the 20, and here we have twice the 80. So now once SQL done sorting the data, what's gonna happen? It's gonna start assigning a rank. So the row number gonna go and assign a unique number for each row. So that means it's gonna start with the first one. The 100 gonna be the rank number 1. The next one gonna be rank number 2. The 80 gonna be rank number 3, and the 54, and then the last one gonna be 5. And now if you check the output, you can see that all those numbers are unique. We don't have any repetitions. So 1, 2, 3, 4, 5, there is no repetitions. They are unique, distinct value, and as well there are no skipping of ranking. So that means we have here 1, 2, 3. There is no jumping to 6, 7 or something. There are clear sequence of distinct value, and there are no gaps. But still there is something special in our data. We can see that in the sales, we have the same value twice. So we have two rows with the same sales. As you can see in the row number, they will get distinct value. So they will not share the same ranking. So that means row number does not handle the ties. If you have multiple rows sharing the same values, they will not share the same rank. They're gonna have a distinct rank, different ranks. So this is how the row number works in SQL. It generates unique ranks for each row. It does not handle the ties, and as well, it doesn't leave any gaps, so there is no skipping of ranking. So now let's go to SQL in order to have few examples and use cases. Alright, so now we have the following task. It's very simple. Rank the orders based on their sales from the highest to the lowest. So now this is very easy. We're gonna go and select first the data. So order ID, product ID. Let's take the sales as well and select the table. So it's going to be sales orders. Let's go and execute it. So with that, we got all our orders. What we're going to do now is to assign for each row a rank. So that means we need a column here that contains the rank for each row. So in order to do that, we're going to go and use the window function, row number. It doesn't accept any argument inside it, so it should be empty. And then we have to define the window. So as we learned in the ranking functions, we cannot leave it empty. We have to sort the data using order by. So order by is a must. We don't have to use any partition by, so we're gonna rank all the data that we have inside the table. So how to sort the data? It says it should be based on their sales from highest to lowest. That means we order by sales. Since from highest to lowest we have to use the descending. And now we're gonna go and give it a name, sales rank, and let's say row, since we are using the row number. So that's it. It's very simple. Let's go and execute it. So now let's have a look to the results. Before, SQL did sort the data by the order ID since we didn't define anything. But since now we are order by sale descending, SQL went and sorted the data by the sales from the highest to the lowest and start assigning a rank, or let's say an integer, unique integer for each row. So now the highest order gonna be the order number 8. We have the sales of 90. This is the highest one. So as you can see, we have 1, 2, 3, 4, 5 until 10. So now by checking the result, you can see that the ranking here is unique. So there is no duplicates over here, and as well there is no skipping or gaps. So we have everything between 1 and 10, even though that we have in our data a couple of sales that sharing the same value. So for example, we have those two orders. You can see both of them has the 60 at the sales, but they don't share the same ranking, right? So we have here as well the 9 and 3, they share the same value 20, but they don't share the same ranking. So with that, we have solved the task. It's very simple. We have now a rank based on the sales from highest to the lowest. Alright, so what is a rank function? In SQL, the rank function gonna go and assign for each row a number, a rank, and this time it's gonna go and handle the ties. So that means if in your data you have two rows having the same values, they're gonna share the same ranking. One thing about the ranking function is that it's gonna go and leave gaps in the ranking, so there is possibility of skipping ranks. In order to understand how the rank function works in SQL, we're gonna have a very simple example. Alright, so again with the same data but with different function. So our window looks like this. It starts with the function rank, doesn't accept any argument inside it. Then we have the window like this, order by, sales, descending from the highest to the lowest, and our data is already sorted like that. So now how is SQL gonna go and assign the ranks? The first row gonna be the highest rank, so the value 100 gonna be 1, then the second one gonna be 2, but now for the third one, as you can see, we have here two values that are the same, so we have a tie, and this time SQL gonna go and as well let them to share the same rank, so both of them gonna be the rank 2. So it's not like the row number where we have over here 3, this time we have 2 because we have a tie. So having same values means they're gonna share the same rank. And now moving to the next value gonna be a tricky one, because if you check over here you can see that the next rank should be like the 3, right? So we have 1, 2, and then the next value that generated in the rank should be 3, but SQL gonna say, you know what, this value position gonna be number 4. So as you can see, 1, 2, 3, 4. So actually the position number here is 4, and SQL gonna go and give it the rank of 4. So with that, SQL gonna be leaving a gap in the ranking. You can see we are skipping the rank number 3, and this always happens once you have a tie where you are sharing the same ranking. So for the next one, it's gonna be easy. It's gonna be the row number 5. So now by looking to the output of the rank function, you can see that we don't have a unique ranking here. We have shared ranking in case of the tie, so it handles the ties, but here we have gaps in the ranks, so we are skipping ranks. When I think about the rank function, I think about the Olympics. If two athletes tie for the gold medal, the first place, there will be no silver medal for the second place. The next medal gonna be given to the bronze, to the third place. Alright, so now let's go in SQL in order to practice the rank function. Alright, now we're gonna go and solve the same task but using the rank function. So what we're gonna do, we're gonna stay with the same example over here, and we're gonna rank the order based on their sales from highest to lowest, but this time using the rank function. So we use the rank and everything inside is gonna be empty, and then our window gonna be exactly the same as before. So over, order by, sales, and disk. So let's give it the name sales rank. Yeah, let's give it a rank. So that's it. As you can see, the syntax is very simple and very similar to the row number. We just changed the function. So now let's go and execute this in order to check the results. So now let's go and check the results by looking to the new rank. If you go and compare it with the old rank, we can see that we are sharing some ranking, right? We have here the 2 twice, so the rank number 2 we have it twice because we have over here the same value. So 60 60 we have it here 2 and 2, but if you compare it to the row number, you can see that it is not sharing the same ranking. So this is one difference, and as well here the same thing, they have the same value. The sales is 20, so we have it twice, the rank number 7, and here we have it as different values, and the next value, as you can see, we are skipping the rank, so there is gap. There is no rank of 8, so you can see that this is the row number 9, and that's why it gets the 9. The same thing I believe over here. So now if you check those two ranks, the next one should be 3, but since it is in the row number 4, it's gonna get the rank 4. So by checking the results, we can see that sharing the same ranks, and as well we have gaps. So this is how the rank works. Alright, so what is a dense rank? It is very similar to the ranking function. It's going to go and assign for each row a number, a rank, and it as well handles the ties. So same values, they're going to share the same ranking, but this time it doesn't leave any gaps like the rank function. So the dense rank, it will not leave any gaps, it will not skip any ranking. So in order to understand this, we're going to have a very simple example. So let's go. Alright, so again, the same data, but with different function. We have this time the rank function, dense rank. And the window gonna be the same, order by sales descending from the highest to the lowest. So now the data is as well sorted already. Let's see how SQL gonna go and assign the ranks. As usual, the first row gonna be the rank number 1, the second as well. But again, here we have the same values. So we have same values and it's like the rank. It's gonna go and share the same rank. So both of them gonna have the rank number 2. And now you might say, well, this is very similar to the rank function, so why do we have dense rank? I'm gonna say, wait for it. We're gonna have the difference in the next value. So SQL gonna come over here. This value is exactly after the tie. In rank, SQL went and took the position number. So the row number, it was 4, right? So 1, 2, 3, 4. But this time with the dense rank, SQL will not leave gaps in ranking, so there will be no skipping. The next rank in the sequence gonna be 3. So that's why we're gonna have the rank 3 for this value. So as you can see, there is no gap. We have 1, we have 2, and 3. So we are not skipping, we are not leaving any gaps. And the last one gonna be 4. So this is exactly the difference between the dense rank and the rank. So now by checking the output of the dense rank, you can see that we don't have unique ranks. We have here shared ranks. As you can see, we have here repetition. So it handles the ties and as well, it doesn't leave any gaps. It doesn't skip anything in the ranking. Okay, so that's it. Now let's go back to SQL to practice the dense rank. Alright, so now we have the same task, rank the orders based on their sales from highest to lowest. So we're gonna do the same stuff, but this time using the function dense rank. So dense rank is gonna be empty, and then we're gonna define it like all others over order by sales disk, and then we're gonna give it the name of sales rank dense, and that's it. So as you can see, all of those functions having the exact syntax, right? So let's go and execute it. Okay, so now let's go and check the results. We got our newest rank using the dense, and by just checking the results, you can see that it handles the tie. We have 2 twice, right? So let's check the example over here. We have the sales 60 twice. That's why they are sharing the same ranking in the dense and as well in the normal rank. But now what is interesting is the value after the tie. So as you can see over here, with the dense rank, we have 3. So we didn't skip any ranking, we don't have any gap, 1, 2, and then 3. But with the rank, it's just focused on the position number, so it is the row number 4, that's why it's 4. With that we have a gap. So as you can see, now we don't have any gaps in the dense rank, so we have 3, 4, 5, and now we have over here the same 2 values. So we have sales of 20, 20, and they share the 6 twice. So as you can see, there is difference now between the dense and the rank. So here we have 7, 7, but here we are at the rank 6, 6. So that's why we have differences between them, because we skipped before in the rank number 3. Now the other stuff you can see, we have 7 and 8. So now if you compare those 3 ranking, you can see that they all start with the rank number 1, but they didn't all end with the same ranking. So the row number and the rank, they really focus on the position number or the row number of the orders. So you can see over here, it is the row number 10. That's why we have here 10 and 10. So the scale is from 1 to 10, and that is exactly the same for the row number from 1 to 10. But with the dense over here, we have it from 1 to 8, and that's because we shared the same ranking, and with that we wasted, let's say, few ranks. So the scale is different from the 2 others, and that's because we have ties twice. This is 1 tie, and as well we have over here 1 tie. That's why we are missing over here 2 ranks. So this is how the dense ranks works, and you can go and compare now all 3 together in order to understand how those ranks are working. Alright, so now let's quickly compare the 3 functions side by side. Let's start with the first point about the uniqueness of the rank. And if you compare those 3, you can see that only the row number generates unique distinct rank. So this is going to be unique rank, and the 2 others, we have duplicates, or let's say shared ranks. Okay, so now the second point, whether the function handles the ties, and the only one that doesn't handle the ties is the row number. So this one doesn't handle the ties, and the 2 others handles the ties since they offer the shared rank. And now we have the last point about leaving gaps or skipping ranking. So now if you check the row number and the dense rank, you can see there will be no skipping. So there is no gaps for the row number and as well for the dense rank. Only for the rank function, the middle one, we are skipping ranks and we are leaving gaps. So that's it guys, this is the differences between those three functions. I tend usually to work with the row number more often than the two others. Alright guys, so now I had a look to those three functions and I checked my projects, real projects, and I found out that there are many use cases for the function row number compared to the other functions, dense rank and rank. So now what we're gonna do, I'm gonna show you a few use cases for the rank number that I usually use in my real projects in order for you to understand how important is the row number function. So let's go to SQL. Alright, so now let's start with the first use case and we have the task of find the top highest sales for each product. So this is very classic. In reporting or data analysis, we call this top N analysis. So here the managers or decision makers, they would like to have the best performers or the best success in our data. So for example, the top highest 5 customers or the top 5 products or categories and so on. So this is very important analysis in order to focus on the best products or onto the most important customers and so on. And this is, as I said, very classic and very important in order to make decisions in the business. So now let's see how we can solve this. So we're gonna start with the usual stuff. Let's first select the data. So select order ID. Let's take as well the product ID and the sales from sales orders. So let's go and execute this. And now as we know that for each product we have multiple orders and we have multiple sales, but we are interested only in the highest sales for each product. So we have to go and create a rank. In order to do that, we're gonna use the row function, row number, and we have to define the window now. So do we need partition by? Check the query. So it says for each product. That means we have to divide the data by the product ID. So let's go and use the partition by products ID. And now we must use the order by. So order by. And now how to sort the data? By the sales, right? And it is from the highest to the lowest. So let's go sales. And we have here descending. So from highest to lowest, let's go and give it a name. So you're going to be rank by products. So let's go and execute this. And now by looking to the result, you can see that SQL did divide the data by the product ID. So we have here like around 4 windows. The first one over here, you can see that the rank starts from 1, ends with 4. So the highest rank can be the order number 8 with the sales of 90. And then it goes to the 4. Now, as you can see that the second window, we have a new ranking, so it resets. The first gonna be the order number 10, and the last one gonna be order number 2. So as you can see, each window has its own ranking. And as well, the last one, we have it only as one row. So now, of course, in the task, we have to return the highest. So we are not interested in the others. We have to return this row as well, and this one, and this one. So as you can see, we have to return everything that has the rank 1. We are not interested in the rank 2, 3, 4, and so on. So we would like to have the highest. So now in order to filter the data, what we're going to do, we're going to go and use subqueries. So select star from, and then we're going to have the following condition. So where, and we're going to say rank by products equals to 1. So we are interested only on the rank number 1. So let's go and execute it. And with that, since we have 4 products in our data, we're going to have only 4 rows and we have the highest sales. So as you can see, we have only number 1 over here and those sales are the highest for each product. And with that, we have solved the tasks by finding the top N analysis. Okay, moving on to the next use case, we have the following task and it says, find the lowest 2 customers based on their total sales. So now we have the exact opposite use case. We call it button N analysis. So now in this example, in the business, the decision makers want to optimize the costs, want to cut costs. And with that, they have to analyze the lowest performers in the product or the lowest performance in the employees in order to cut costs. So now with this analysis, the decision makers are not focusing on the best successful stuff, we are focusing on the lowest stuff, the lowest performers. So now let's solve these tasks. So now if you check the question, we have multiple stuff, right? We have the total sales, And as well, we have to find the lowest two customers. So we have ranking and as well aggregations. Remember, we can do stuff together with the group by. So now let's do it step by step. First, let's select the data, right? So what do we need? Order ID, customer ID, and we need the sales from sales orders. So let's go and execute this. So now if you check the customers over here, we have around 4 customers and they have multiple sales. Now we would like to have the total sales for each customers in order to find the lowest two. So let's start first with the aggregations. So what we're gonna do, we're gonna go and aggregate the sales. So the sum of sales, let's call it total sales. And now in order to do the group by, we have to have only the customer. So group by, and we have the customer ID. So it is very simple group by statements. Let's go and execute this. So now by checking the result, we can see that SQL did aggregate the data. We have 4 rows, and that's because we have 4 customers and we have their total sales. So we have solved the first part of the task. We have the total sales for each customers. Now let's move to the second part. It says lowest 2 customers. That means we have to use the ranking functions in order to rank those customers. So we are not interested in all customers, we are interested only in the lowest 2. So in order to do that, now we're going to go and use the window function, row number, so, and then over. Now, do we have to partition the data? Well, no, we don't have to do that. We have now to sort the data, so order by. So this time we're going to go and use the aggregations in the order by, so the sum of sales, and we want to have it sorted from the lowest to the highest. So I'm just going to go and use the defaults. So it is ascending. Now let's call it rank customers. So that's it. Again, here the rule is that if you are using a window function together with the group by function, you have to use only columns that is used in the group by. So this should be working. Let's go and execute it. So now as you can see in the results, we got an extra column for the rank. So now the lowest customer going to be the customer number 2. The second one going to be 4 with the 90 total sales. And the highest customer with the sales is going to be the last one, the 125 customer number 3. So now we have almost everything, but the list should contain only the last 2. So in order to do that, to filter the data, we're going to go and use subquery. So select star from, and then we have to define the condition where rank customers, it should be smaller or equal to 2, right? So with that, we will get the first 2. So let's go and execute this. And with that, we got the lowest 2 customers based on their total sales. So customer number ID 2 and the 4. So that's it. We have solved the task. And now we have done button in analysis. Okay, let's keep moving to the next use case. And we have the following task. It says, assign unique IDs to the rows of the table orders archive. So now guys, we might be in a situation where you have a table without any primary key and you would like to create an ID for each row. So in order to do that, we can use the function row number in order to generate unique identifier IDs for each row inside our table if we don't have one. And generating such ID for each row, it's very important to do stuff like importing data, exporting data, maybe joining tables as well using this ID, or let's say optimizing the performance of query using the ID. So now let's see how we can generate that using row number. Okay, so now let's first select the table order archives in order to understand the content. So select star from sales orders archive. So let's go and execute. So now by checking the result, you can see that we have 10 orders and we have repetitions in the order ID over here. So it is not really a primary key. As you can see over here, we have twice the ID 4 and here we have 3 times the ID 6. So now what we're going to do, we're going to go and generate unique identifier for each row. So in order to do that, what we're going to do, we're going to go over here and say row number. And then we're going to define the window function. We don't partition the data at all, but we have to sort the data by the order ID. So order by order ID, or you can use something else as well using the order date or something, doesn't matter. So let's add to it order date as well. And let's call it unique ID. Let's go and execute this. Now by checking the data, you can see that we have a new ID over here that comes from the row number, and we have like a unique identifier. As you can see, we have 10 rows, and with that we have as well 10 different distinct unique IDs. So with this, as you can see, we have solved the task and we have now a unique identifier, an ID for the table orders archive. So now having this ID, we can do many stuff like joining tables or doing something special and important called paginating. Imagine we have like a huge table and we would like to retrieve the data. So now in order to not have all the data in one go, we can go and divide the data by the primary ID or by unique identifier. For example, we can make a page from 1 until 100,000, and then the second page starts from 100k to 200k. So now by dividing the data, we can maybe improve exporting or importing data, or we can have faster retrieval for the users. We don't want to have the whole data in one go, in one page. So it has a lot of benefits using paginating, and we can do that only if we have a nice ID like this. Alright, so now I'm going to show you the last use case for the function row number that I usually use in my real projects. So sometimes if you are doing data analysis, you're going to find out that there are data quality issues, especially with the duplicates. So what I usually use, I use the row number in order to identify the duplicates. Not only that, I can use it in order to delete the duplicates. So we can use it in order to do data cleansing, and this is essential task for each data engineer, not only data analysts, in order to prepare and clean up the data before doing data analysis. So let's have the following task. Identify duplicate rows in the table orders archive and return a clean result without any duplicates. So not only we have to identify the duplicates, we have to return no duplicates in our results. So let's see how we can do this. Let's first select the data. So select star from sales orders archive. So let's go and execute. So now by looking to the data, you can see that we have duplicates. We have an issue. So the order ID number 4 is twice in our database. It doesn't make sense, right? It should be only one. So which one is the correct one? If you check the data over here, you can see that this order is shipped and then delivered. So it looks like the last one is the correct one. So how we can do that? If you just scroll to the right, you can see that we have a creation time, and we usually use such a timestamp in order to identify what was the last valid like order. And here we can see immediately that this order time is higher than the previous one, which means this is the more up to date, right? The more current. So what we're gonna do, we're gonna go and rank our data for each order ID and sort the data by the creation time in order to find the last inserted or created row for this order. So let's see how we can do that. What we're gonna do, we're gonna go over here and say, let's have a row number, and then over, and what we're gonna do, we're gonna partition by the primary key. So partition by order ID, and as we said, we have to order the data by this timestamp at the end. So partition by or order by creation time and descending. So we want the highest, then the lowest. So that's it. Let's call it RN and execute the query. So now by checking the data, if everything is clean and we don't have duplicates, everything should be 1, because maximum for each primary key we should have 1 row. So but you can see over here we have here 2 and we have here 3, 2. So that means this is indicator that we have duplicates inside our data. So now by checking one by one, as you can see, the order ID is only 1. So we have the rank 1, the second one as well, we have the rank 1, but here we have the issue. So as you can see, we have now 2 ranks for the order ID 4. So now which one is the correct? In our logic, we said it is the last row that is inserted inside our data, and this is rank number 1. So if you scroll to the right side, you can see that the creation time here is higher than the second one. So with that, we have identified what we want. We want the last inserted row for each ID. And now let's check this over here. So here we have it 3 times. So it says the first one is the highest creation date. So if you go to the right side, and now by comparing those timestamps, you can see that this record, the first one, is the latest one that is inserted inside our data. So as you can see, this one is the one that we need. The other 2, we don't need it because it is old informations. So now everything that doesn't has the rank number 1 is not valid. It's something old and it's actually bad data quality, so we want to remove it or not to select it. So now in order to have a clean data, what we're gonna do, we're gonna go and select the following as subselect. So select star from the table, and now we are interested only with the rank number 1. We don't need anything else. So let's go and execute. And now if you check the results, you can check the order ID over here. It is unique. We don't have any duplicates, right? 1, 2, 3, 4, 5, 6, 7. There is no duplicates at all. and we have now only the latest inserted data inside the orders, and we don't have any duplicates or data quality issue. So now, of course, now we can go with this result in order to do further analysis, and this is exactly what data engineers usually do: clean up the data and prepare the data before doing any data analysis. And of course, if you want to communicate those data quality issues to the source of the data, let's say you are not the owner of those informations, you can generate a list of all bad data quality issues and you can send it to the source system and tell them to clean it up from the sources. So now, in order to select the bad data, what we're gonna do is we can just change here the condition and say if it is higher than 1, then you are like bad data. So let's go and execute this. And now with this, we have in the results all records that shouldn't exist in the data in the first place. So we can go and export it and communicate it to the source and tell them, check here, you have something wrong in your system and those informations should not be inserted in the data. So everyone, it is very strong, right? It is very powerful. I use it a lot in my projects. There are many use cases for the row number function in SQL. We can do it in order to find the top n analysis, the bottom n analysis, the best performance, worst performance, and as well we can assign unique IDs to do paginating, or we can use it in order to discover data quality issues to clean up our data. So it is amazing function in SQL and you're gonna use it a lot. So that's it for the 3 functions: row number, rank, and dense rank. Now we're gonna talk about the NTILE. Okay, so what is NTILE? NTILE in SQL is very simple. It's gonna go and divide your rows, your data, into specific number of almost equal groups, or sometimes we call them buckets. So now, in order to understand this and how SQL works with this function, we're gonna have a very simple example. So let's go. Okay, we have the following setup. We have 4 rows, 4 cells, and we would like to divide it into 2 groups or into 2 buckets. So in order to do that, we can use the NTILE function. It has different syntax than the other ranking functions. So it starts with NTILE, then we must define a number. So we cannot leave it empty like the other ranking. So here we have 2 buckets, then over, and here again we have to sort the data. So it is must order by sales, descending from the highest to the lowest. So now, as usual, SQL gonna go and sort the data. We have it already sorted in this example. Then it's gonna start assigning each of those rows into buckets. But SQL first has to calculate the bucket size. So how many rows we can like insert inside each bucket. So the calculation is very simple. It says the bucket size equals to the number of rows divided by the number of buckets. So what is the number of rows here? We have 4 rows, right? So we have 4 over here. Then the number of buckets, we define it in the syntax of the query. So here we defined 2 buckets. We need 2 groups. So that means we are dividing 4 by 2, and the size of the bucket is going to be 2. So now with this, SQL is ready and going to start assigning each row to a bucket. So it's going to start on the top. The first one going to be in the bucket number 1, then go to the next one. It's going to say, okay, we still have enough space in the bucket, right? So it's going to assign it as well to 1. But with this, we reach the maximum number of rows within each bucket. So the next row going to be assigned to another bucket. So it's going to be 2. And the last one going to be as well 2. So as you can see, it's very simple. We have just assigned our sales based on the sorting, of course, into 2 buckets. These 2 sales belongs to the bucket number 1 and the other 2 belongs to the bucket number 2. Very easy. So that's what's very straightforward because we are dividing even numbers and we got perfectly sized buckets. But now what can happen if we have an odd number? So we have here 5 instead of 4. So the bucket size is going to be dividing 5 by 2. We're going to get 2.5. And now, of course, SQL will not go and divide like 2 halves for each bucket. Then we are splitting this into 2 buckets. Of course, this will not be working. We should have now a bucket with 3 and another bucket with 2. So now the rule in SQL make it very clear. It says larger groups comes first, then smaller. So that means if we have here an even number like this, the larger group going to be the first group. So that's gonna look like this. It's gonna like reset everything. So let's see what's gonna happen. The first one gonna be 1. The second one as bill 1. The third one gonna be as well 1. So it gonna has a larger bucket than the second one. Then the rest gonna be 2. So as you can see, the larger group comes first, then the smaller. And this is how SQL gonna work if you have odd numbers. So you don't have here perfectly sized buckets. You have approximately or roughly equally sized buckets. So this is how the NTILE works. Now let's go back to SQL in order to practice this function. Okay, so now let's have some fun working with this function. So we're just gonna select something like order ID, sales, from sales orders. So let's go and execute it, and with that we got our 10 rows. Now let's say that I would like to create only one bucket from the data. So NTILE and only one bucket over partition. Let's say not partition by, let's take order by sales descending. So that's it. I'm gonna call it one bucket. So let's go and execute it. As usual, SQL gonna go and sort the data and then calculate the bucket. It's gonna be 10 rows divided by 1. So the size of the bucket gonna be 10. So that's why you're gonna see everywhere here as a 1, because all those rows gonna fit into one bucket. So this is very simple. We have only one bucket. Let's go and now have two buckets. So I'm just gonna copy and paste, and instead of one we're gonna have two, and let's call it two buckets. So let's go and execute this. So now here again, what is the size of the buckets? It is 10 divided by 2. So we will get perfectly grouped buckets. So the first bucket gonna be 5 rows, and the second one gonna be the next 5 rows. So it is very perfect. Let's go to the next one. Let's have 3 buckets. So 3. So let's go and execute. So now what's gonna happen is SQL gonna go and divide 10 by 3 in order to get the size of the bucket, and it's gonna be 3.3, so it is decimal, and we will not get perfectly sized buckets. So again, the larger group comes first and then the smaller. So as you can see, we have to fit then in the first group 4 in order to get the others with 3. So that's why the first bucket is gonna be the biggest one. So 4 rows into the first bucket, then the second 3 rows gonna be in the bucket 2, and as well the last one gonna be bucket 3. So as you can see, the largest group is gonna be the first bucket. So now let's keep playing with the data. Let's go and take now 4. We would like to have 4 buckets. Now things gonna get interesting. So now by checking the results, it's gonna be interesting. SQL gonna divide 10 by 4 and we will get something like 2.5. So again, we will not get perfectly sized groups. So SQL has to fit now 10 rows into 4 groups. So the first 3 rows gonna be fit in the bucket number 1, and as well the second 3 rows like this gonna be in the bucket number 2. And then you can see over here we have 2 buckets with the size of 2, and with that we can fit 10 into 4 groups. And again, you can see the larger groups comes first like this one, and then the second, and the smallers comes later. Okay, so this is how the enter works in SQL. And now you might say, you know what, why do I need buckets in the first place? So what is the use case? There is 2 use cases for the NTILE function in my project. In one hand, if I am data analyst, I'm going to use the NTILE function in order to segment my data. In the other hand, if I'm data engineer, I'm going to use the NTILE function in order to do ETL processing and as well to do load balancing. So now let's start with the first use case as a data analyst, where you want to do segmentations with the NTILE function. Segmentations is a very nice way in order to understand your data. So you can go and segment your data into different buckets or groups, like for example, doing segmentations for the customers. So you can go and group up your customers depend on their behavior, like the total sales or the total number of orders. So with that, you can make, like for example, VIB section, and then the medium, and then the low. So now in order to understand the segmentation use case, let's have the following task. Okay, the task says segment all orders into 3 categories: high, medium, and low sales. So in order to solve this, let's do the basic stuff, right? So select order ID. Let's take the sales from our table, sales orders, and let's go and execute it. So as usual, we got our 10 sales. So now if you check the task, it says we need 3 categories. So that means we need 3 buckets, right? And it says high, medium, and low sales. So that means we are dividing by the sales. So let's go and do it step by step. So we're going to use NTILE since we need to segment the data. 3 categories means 3 buckets. And then let's define the window over. We don't have to divide the data by partition by. We just need to sort it first by the sales. So it's going to be by sales, and let's take discrete since we want to sort it from the highest to the lowest. So that's it. Let's say you are our buckets. So let's go and execute this. So now if you check the data, you can see that they are segmented into 3 buckets. So the first bucket is going to contain all orders with the high sales. Then the second one going to be all sales with the medium. And then the last one going to be all sales with the low sales. So as you can see, we have already categorized our data into 3 groups. But now as you can see, we have numbers And maybe the user is expecting to have those text, high, medium, low. So that means what we're going to do now, we're going to go and translate those numbers into text, into words. And of course, we cannot do that inside the window function. We're going to use data transformation using the case when statements. Don't worry about it. We're going to have a complete dedicated section explaining the case when. So for now, just follow me in order to see how this works. We're going to go and use subquery. So it's going to be select. And let's take the star for everything, and then let's have the following logic. Case when buckets equal to 1, then it is high. The sales is high. So we are just mapping the numbers into text. So otherwise, case when the buckets equal to 2, then we are targeting the medium, and then the last group, buckets equal to 3, then those sales are low. So let's call it end it, and let's call it sales segmentations. So that's it. Let me just make it a little bit smaller in order for you to see it. And all right, so from, and then we have our subquery like this. So as you can see, we just mapped the numbers into text. We are just doing translations. So let's go and execute it. And now by checking the results, we got our 3 categories for the users. So the first category is going to be the high sales, the second one going to be the medium sales, and the third one going to be the low sales. So guys, you see, NTILE is very powerful in order to segment our data. So now you can go and segment stuff like the customers by their total sales, or the products by prices, employees by their salaries, and so on. Alright, so this is the first use case for the NTILE function as a data analyst, where you go and segment your data in order to understand the behavior. Now, in the other hand, if you are a data engineer, you can use NTILE function in order to do load balancing in your ETL. So now I'm just going to explain it in very simple sketch. Alright, so now we have the following scenario where we have 2 databases, and we would like to move one big table from the database A to database B. So in this case, I'm doing something called full load. That means I'm loading all the rows from one database to another. So if you do it in one go, what could happen is that it could take a long time. So it could take hours or even sometimes days. And maybe at the end, you will get maybe some network errors because you have stressed the networks between those 2 databases, and everything gonna break and you're gonna lose the data and you have to start again. So now instead of loading this table in one go, what we can do, we can go and split it into fractions, or let's say buckets. So we can split this table, for example, into 4 small tables using the function NTILE. So now after we split this big table into small tables, we can go and start moving those small tables one after another, and with that we are not stressing the networks and it's gonna succeed. So now after loading everything at the end in the target database, we're gonna have those small tables, and of course we can go and use the union in order to merge them, in order to have again the big table that we have it in the original database. So this is very common use case for the NTILE in order to split the load and to balance the processing of extracting data. Alright, so now we have the following SQL task. It says, in order to export the data, divide the orders into 2 groups. So let's go and do that. First, we're going to select everything from the table, just in order to see the data, sales, orders. So let's go and execute it. So now we got our 10 orders, and what we have to do is that to go and split it into 2 groups. In order to do that, we can use the NTILE function. 2 groups means 2 buckets. So let's define the window. So here we don't have to partition the data using partition by, but we have to specify the order by. So now which column we're going to use in order to sort the data. Of course, here there is no rule, like you can go and split the data by sales or by the order status, by date, by anything you want, but we usually go and use the primary key. It's just systematic, better and more clean, especially if you have a sequence of numbers in the order ID. So you can export the first range of the orders, then you can go to the next group and so on. So let's go with the order ID and let's give it a name, buckets. So that's it. Let's go and hit execute. Now, as you can see, it's very simple. We got our 2 groups. So this is the first batch of the data, and this is the second batch of data. So now we can go and select the first batch and export it, import it in the next system, and then after that we go with the second batch. And of course, if you still suffer from the size of those buckets, you can go and split it to more smaller size. So you can go over here and make it 4. So with that, we're gonna get smaller buckets and it might be easier to export the data. So this is a really great use case for the NTILE function. Alright everyone, so with this you have learned the two use cases for the NTILE function that I usually follow in my projects. So as a data analyst, you can use it in order to do segmentations, and as a data engineer, you can use it in order to do load balancing of the ETL. Okay everyone, so with that we have covered everything about the integer-based ranking functions. Now we're gonna talk about the second methods. We have the percentage-based ranking functions, and here we have two functions, the cubedist and as well the percentile. So now let's have a quick recap. So with the percentage-based ranking, SQL gonna go and calculate a relative position as a percentage and assign it for each row. So the output gonna be a continuous normalized scale from 0 to 1, and this is really amazing in order to do distribution analysis. So those functions gonna consider in their calculation the overall total, the whole size of the dataset, which can help us in order to find out the contribution of each value to the overall total. And now in SQL, in order to generate the percentage, we have two different formulas. So in one hand we have the function cubedist, and in the other hand we have the percent rank. So that means we have two different functions with different formulas in order to generate and calculate the percentage. So now let's start with the first function, the cubedist. Alright everyone, so now let's start with the first function. We have the cubedist and it stands for cumulative distribution. It's gonna go and focus or calculate the distribution of your data points within a window. So what this means, in order to understand it, we're gonna go and have a very simple example to understand how SQL works with this function. So let's go. Alright, again we have our very simple example of the sales, and we have the following query. So cubedist, then we don't give any argument inside it, so it's gonna be empty, and the window gonna be like usual, order by sales, descending from the highest to the lowest, and the order by is a must. So the first step, SQL gonna go and sort the data. We have it already sorted from the highest to the lowest. So now the next step is that SQL gonna go and start calculating the percentage for each row, and we have a very simple formula. It says the cubedist equals to the position number of the value divided by the number of rows. So now the next step, SQL gonna go and start calculate the percentage for each row, and we have this very simple formula. It says the cubedist equals to the position number of the value divided by the number of rows. It's very simple. Let's do it step by step. So SQL gonna start with the first value in our list. So it's gonna be calculated like this. So what is the position number of the first value? It's gonna be 1, right? So this is the first value in our list. And what is the total number of rows? We have 5 rows, right? So 1, 2, 3, 4, 5. So we're gonna divide 1 by 5, and the result gonna be 0.2. So this is gonna be the first value for the first row. Okay, so now SQL gonna go to the next row, and this time we're gonna get a special case. As you can see, we have the 80 twice. So we have here a tie. So now first we need the position number. As you can see, we are at the position number 2, right? But since we have the 80 multiple times, SQL gonna go and take the last position that we see the value 80, and the last position gonna be the record number 3. So that's why SQL gonna say for this record it's gonna be the position number 3 and not 2, and then it's gonna go and divide it by 5, and we will get the value of 0.6. So this is the most confusing thing with this function. So if SQL finds a tie, it will completely ignore the current position number, so we don't have 2. It's gonna go and take the last position number for the same value, and the last in our list gonna be the record number 3. So that's why we have 3 over here. Okay, so now let's keep moving. Let's go to the third row, and as you can see, we are again in the tie, but this time this is the last time we see 80. So next we don't have 80. So what's gonna happen? We're gonna have exact same results. So it's gonna be 3 divided by 5. So as you can see, if we have a tie, they're gonna share the same percentage. So that means with the cubedist, if you have same values, they're gonna share the same rank. So let's keep moving to the fourth one. So now what is the position number of the 50? We are at the record 4. So position number 4 divided by 5, we will get 0,8. Okay, so now let's move to the last one, and it is the easiest one. So which position do we have over here? It is the position number 5. It's the last one, and the number of rows is 5. That's why we will get 1. So guys, that's it. This is how the cumulative distribution works. Once you understand the formula, it's going to be very easy in order to understand the output. So as you can see, calculating the percentage always depends on the total size of our data sets. You can see here the number of rows. So with this, we're going to get an output that helps us in order to understand the distribution of our data points within the data sets. Alright everyone, so now we're going to go and focus on the second function that generates percentage as a rank. We have the percent rank. So the percent rank going to go and focus on generating the relative position of each row within a window. So in order to understand what this means, we can have a very simple example in order to understand how SQL works with this function. So let's go. Okay, again we have those cells, very simple example, and the syntax going to be like this. Percent rank, and inside it we don't use any arguments, and the window gonna be like this, order by, it is a must, sales descending from the highest to the lowest. The first step that SQL gonna do is that's gonna go and sort the data from the highest to the lowest, and we have it already like this. And next SQL gonna go and start calculate the percentage, which is very similar to the cumulative distribution, but this time it's gonna be like this. Position number, then we subtract it from 1, and as well divided by the number of rows subtracted from 1. So it's like exact formula, but we are only subtracting here once for both numbers. Okay, so now let's go through all rows step by step and see the output. So SQL gonna start with the first row, right? So what is the position number of the first row? It's gonna be 1. Then we have to subtract it by 1. That's why we will get 0. Now what is the total number of rows? We have here 5 rows, and it is subtracted by 1, that's why we're gonna get 4. So now 0 divided by any value, the output gonna be a 0. So that's why for the first value we will get a 0. Alright, so now let's move to the second row over here, and here we have our special case where we have a tie. So we have two cells sharing the same value 80. So now for the percent rank, SQL gonna have different behavior than the QMDist. Remember in the QMDist, SQL did search for the last position of the shared value. So it was the position number 3, since this is the last time we see 80. But now with the percent rank, SQL gonna stick with the first occurrence of the shared value. So now by checking those two 80s, what is the first occurrence? It is the record number 2. So that's why we have position number 2 subtracted by 1, we will get 1, and here the same gonna be number of totals. We have 5, subtract by 1, we have 4. So now if you divide 1 by 4, we will get the result of 0,25. So this is the percentage of this value. So now let's go to the second row. Here we have again the tie. So SQL gonna stick with the position number 2, the first occurrence. So it's gonna be the same. 2 subtracted by 1, we will get 1, and as well the total number of rows, 5, subtract by 1, we will have 4. That's why we will get the same exact results. So here as you can see, with the percent rank, it's like the QMDist, the shared value gonna share as well the same percentage rank. Now let's move to the fourth one. So we have the value 50. So what is the position of this? It's gonna be the record number 4, subtracted by 1, we will get 3, and if you divide 3 by 4, you will get 0.75. And now moving to the last value over here, it's going to be easy. So what is the position number of the 30? It is 5. 5 subtracted by 1, it's going to be 4. And as well, we're going to have 4 as well here for the total numbers subtracted by 1. So if you divide 4 by 4, you will get 1. So that's it, guys. This is how the percent rank works. It always has the scale from 0 to 1. So it's always like this. It doesn't matter which values do we have inside, and it's gonna have like a continuous scale. And again here, if you have a tie, they're gonna go and share the same percentage rank. Okay guys, so now if you go and compare those two functions, you can see that they are really similar to each other's. The output of both functions, we are generating percentage based ranking, and both of them as well handling the ties perfectly, so they share the same percentage rank. If you check the syntax, they are very similar. And now by checking the formulas of both of them, we are always considering the overall size of the datasets. So here the size is considered in the calculation to help us finding the relative position of each value to the overall. And this is very important in the analysis in order to measure the contribution of each value to the overall. So now about the use cases, course, if you want to focus on the distribution of your data points, go with the cumulative distribution. But if you want to focus on the relative position of each rows, then go with the percent rank. Alright, so now there is one more difference between the cum dist and the percent rank, and that's if you check the formulas, you can see that the cum dist is more inclusive. We always consider the position number of the current row, but with the percent rank, we don't consider the current row, we like skip it or make it exclusive. So we say for the percent rank, it is more exclusive, and the cumulative distribution, it is more inclusive. So now if you ask me the hard question, which one to use, I'm gonna say if you want to be more inclusive, go with the cumulative distribution. If you want to be more exclusive with the current row, go with the percent rank. So they are very similar to each other's. So if you want to calculate the distribution of your data, go with the cumulative distribution. If you want to find the relative position of each row, then go with the percent rank. Alright, so now we have the following task. It says find the products that fall within the highest 40% of the prices. Let's go and solve this. Now we are targeting the table products, and I will just select like two columns: product, price, from sales, products. So that's it. Let's go and execute this. So now as you can see, we got 5 products and their prices, and the task says find the highest 40%. So we have to find and generate a percentage rank. In order to do that, we have the two functions, cum dist and the percent rank. I will go this time with the cum dist. So let's go and do that. So cum dist, and then let's go and define the window like this. It's gonna be order by. We are targeting now the prices, right? So order by the price from the highest to the lowest, and let's go give it a name, dist rank. So let's go and execute this. So now with that, SQL can go and generate for us a percentage ranking using the formula that we just learned before. So now in the output, we are getting all the products, but the task says we have to get only the products that are in the highest 40%. So that means the first row, the second row, and that's it. So those rows are in the highest 40%, the rest are below that. So in order to do that, to filter the data, we're gonna use the subquery. So select star from, and then we have our subquery like this, and then our filter gonna be dist rank smaller or equal to 0.4. So this is our threshold in order to get the data. So let's go and execute this. And now as you can see, we got the top products, the top 40%. Now of course you can go and format the percentage. We can do that like this. So let's take the dist rank, multiply it with 100. So let's go and execute this. So now as you can see, we got 20 and 40%. We can go and add to it as well the percentage character, right? So we can go and say concat, and we're gonna add the character after that like this, and let's call it dist rank percentage. So that's it. Let's go and execute it. So that we have solved the task, we have the products that fall within the highest 40%. Now of course you can go and try the percent rank. So it's very simple. We just have to go and switch the cumulative distribution with the function percent rank. So let's go and execute it. Now as you can see, we will get the exact same results. So we're still getting the gloves and caps as the highest products within the 40% of the price. So guys, that's it. It's very simple, right? Alright friends, so now let's have a quick recap for the window ranking functions. So what they're gonna do, they're gonna go and assign a rank for each row within a window. And we have two types of ranking, right? The first one is the integer based ranking. It's gonna go and assign a number, an integer for each row. And here we have 4 functions: row number, rank, dense rank, and NTILE. And the second type of ranking, we have the percentage based ranking. So SQL first is gonna go and calculate a rank and then assign it for each row. And here we have two types of formula or functions. So we have the cum dist, the cumulative distribution, and the second one we have the percent rank. And now to the next point, if we are talking about the rules of the syntax, so the expression should be empty. We should not pass any argument to the functions. We must use order by in order to sort our data, so it is required. And the frame clause are not allowed to use, so you cannot go and customize a frame within the window function. And as we learned, there are many use cases for the ranking functions. For example, we have the top in analyzes, the bottom in analyzes, in order to identify our top performers or the worst performers in our business. Another use case, using the row number, we can identify and remove duplicates in our data, so we can use it in order to find data quality issues and as well to improve the quality. And another use case, if our table don't have a clean primary key, we can go and generate a unique IDs using the row number in order to do as well paginating. One more use case, it was the data segmentations. You can use the NTILE in order to segment your customers, your products, employees, and so on. And another use case, we can do data distribution analysis. As we learned, we can use the QMTest in order to understand the data distributions of our data points compared to the overall. And the last use case, it's more for data engineering. We can use the NTILE function in order to equalize the loading process of our ETLs. So as you can see, there are many use cases for the ranking functions. Alright, so with that you have learned how to rank your data using 6 different SQL window functions and their use cases. They are amazing for data analytics. Now moving on to the next one, we have the last group of window functions. We have the value functions. They are, my friends, the most important group for data analytics compared to the other two. So here we're going to focus on 4 functions. We're going to learn how SQL works with that, the syntax, and as well the use cases. If you like this video and you want me to create more content like this, I'm gonna really appreciate it if you support the channel by subscribing, liking, sharing, commenting. All those stuff gonna help the channel with the YouTube algorithm, and as well my content gonna reach the others. So thank you so much for watching, and I will see you in the next tutorial. Bye.